Hey everybody, this is a second video on chapter 2.6 regarding graphing rational functions. Um, so what I'm going to do is I'm just going to work through some of these problems in the book, give you examples of how to solve uh, some of these types of problems regarding rational functions. So we ended yesterday, or in the last video, on problem 12, I believe, which is where's problem 12? Right here. We did this one, I think. So I'm gonna jump down. Let's jump down and do a couple of these. Let's see. This one says match the rational function with its graph. That should be easy enough to do since you have a calculator. Here it says find the zeros of any of the rational functions. So let's take a look at some of these. And I have not done these beforehand, so it's very possible I could make a mistake, and if you find a mistake, let me know, and if you're first, then you get extra credit. All right, so let's look at number 18. Find the zeros. So I think what I'll do is I'll graph it first, and then we'll work it out by hand. So we're going to graph it and find the zeros, and then we're going to see if we can also find the zeros by hand. So let me put this into I'll write it down here first. So number 18 is 2 plus 5 over x squared plus 2. All right, and that is h of x. All right, so there it is. And we'll put that into Desmos. So h of x equals 2 plus 5 over x. Let me get this out of the way. X squared. Whoops. X squared plus 2. All right, there it is. All right, so as we can see, it doesn't look like there are any zeros, right? It just stays above the x-axis, so there are no real zeros. Of course, there might be imaginary zeros, but we're only looking for the real zeros in this situation. So let me zoom out on that. So let's see if we can figure out why aren't there any zeros on this. So when you look at this function, there's no way to make the top of this fraction 0, right? But it could come out to be 0 if you can make the value of this -2, right? So because 2 plus -2 would be 0. So is it possible that the value of this could be -2? Well, that seems like it would be possible if we divide 5 by something. 5 divided by what, gives you -2. So it would be basically setting this function equal to 0 and trying to solve it. So let's see what happens when we do that. So if I set this function equal to 0, first thing I would do is take away the 2 from both sides. So now I've got 5 over x squared plus 2 equals -2, right? And then you can multiply both sides by the denominator. So now you have 5 equals -2 times x squared plus 2. All right, I could distribute that, I suppose. Let's see, or well, this is a quadratic, isn't it? So let's see, I've got -2x squared minus 4. And then I could bring over the 5 to set it all equal to 0 again. So I would end up with, what? If I take away 5, I'd end up with 0 equals -2x squared minus 9. is there any way this is going to come out to be 0? Let's see. Well, let's bring that. I should have added this to the other side, so I'm kind of going the wrong way, aren't I? So I'm going to add 9 to both sides. So 9 equals negative 2x squared. Divide by 2. I get negative 9 over 2 equals x squared. And there's your problem, right? So I went a long way around to get here, but you can't square a number and get a negative. So that tells me that the only zeros are imaginary zeros, right? It would be basically x would equal plus or minus the square root of negative 9 over 2, which is, with that negative under there, that's an imaginary number. So there are no real zeros. So this makes sense. So let's see what happens if I go way out. What's it going to go towards? I think it's going to go towards, looks like 2, right? So when I say go towards, I mean, what is this graph approaching? What is the horizontal asymptote? And it appears to be 2. So if I do y equals 2, you do see that the graph approaches that line, because this can get very close to 0, but it will never be 0, right? So it does approach positive 2. So we do have a horizontal asymptote. We do not have a vertical asymptote here. All right, so that was number 18. So to answer the question, find any zeros, if any, of the rationals. So we would say no real zeros. All right, and this is how you would show your work. You would set the function equal to 0 and solve and see if you can come up with anything. Now normally, when you have a rational function, whatever makes the numerator of the fraction 0 is what's going to give you a 0 for the polynomial. But in this case, that's not possible. Okay. So number 20, let's check that one out. Number 20. G of x equals x cubed minus 8 over x squared plus 1. All right, and again it says, what are the zeros? Well, the zeros are whatever make this go to 0. And I can see 1. I believe 2 would work, right? Because 2 cubed is 8, and 8 minus 8 is 0. So obviously 2 is a 0. Negative 2 doesn't work because negative 2 cubed is negative 8, and negative 8 minus 8 is negative 16. So you notice I'm ignoring the bottom because it really doesn't matter. The bottom can't be 0 because if you square a number, you're going to get a positive number, and then add 1, you're just going to get an even bigger positive number. So the bottom is always going to be 1 or more. So it looks like the only 0 is x equals 2. Now, we can factor this. So let me see if we remember how to factor. This is a difference of cubes, right? So if it's been a while since we've done this, the method is, I believe, you take the cubed root of x cubed, which is x, minus, you take the cubed root of 8, which is 2. All right, and then you take this first term and you square it to get the next factor, so that's x squared, and then you multiply these two together. But if I remember right, it's a positive, so that's 2x. Hopefully this is coming back to you if you see it. And then you square this last one, so that's plus 4. All right, so that's factored now over. You can't really factor x squared plus 1. If you did, it would be x plus I, x minus I. So all we can do is really just leave it as is. Okay, so I've got two factors on the top. And you can see this one. If you let x be 2, then that's 0. And 0 times whatever that is also 0. So 2 is our only 1. So let's take a look at the graph and see what it looks like. Since we got it up here, we might as well talk about asymptotes and all that as well. Notice that this is what we call, I guess, an improper fraction. If you remember, improper fraction is like 5/3. 5/3 is improper because the numerator is bigger than the denominator. 1/3 is a proper fraction. So this is proper, and this is improper. All right, so in a sense, if you think about the degree of the polynomial, this is cubed root, this is square root, so the degree of the numerator, the polynomial which is the numerator, is greater than the degree of the polynomial that is the denominator. So I'm going to call this an improper. And I know that in this case, when you have an improper fraction, you don't have any horizontal asymptotes. But because this is 1 degree higher, I believe we will have what's called an oblique asymptote. And an oblique asymptote is basically just linear, right? So it's going to be something like this. And the graph will approach that line, that imaginary line somehow when I go to graph it. So let's take a look at what this turns out to be. So I've got g of x equals parentheses x raised to the third minus 8. There's your 0 already. Over x squared plus 1. And there's your 0. And notice how the graph is going up. As I said over here, it's kind of like it's oblique. So I'm going to zoom out so you can see it a little bit better. Notice this line right here. Now, what is that line? I think that line is probably just, if you were to forget about the minus 8 and the plus 1, just look at x cubed over x, because that's all that matters when x is very, very large. That's just going to be x. X cubed divided by x squared is x. So the asymptote should just be y equals x. And there it is. So we can zoom back in so you can kind of see how it behaves in the beginning. But you see how the graph is approaching that purple line, but it will never touch it. Same way down here. This thing. It approaches this way from underneath, but it never touches it. All right, so I'm going to hit the home button there, or I can zoom out. You can kind of see eventually, if I zoom out far enough, it's just going to look like that line. Right? Now you can't even tell the difference. Once x gets large, you really just got y equals x for the most part in the long run, right? When x is very, very large. Okay. So that was number 20. We found the x. We found what's called a oblique asymptote. Just to recap, that occurs when the degree of the numerator is 1 larger than the degree of the denominator. Right? If the degree of the numerator and the denominator are the same, you'll get a horizontal asymptote, but not at 0. And then if it's a proper fraction where the top degree is smaller than the bottom degree, the x-axis itself should be a horizontal asymptote. All right, so that was number 20. So this one, we're doing everything, right? Identify all the intercepts, that's the x and y's. Find any vertical and horizontal asymptotes. Check for symmetry. We haven't done that yet. You remember, symmetry we can check by plugging in negative x and seeing what the outcome is. And D, plot additional solution points as needed and sketch the graph. So the idea here is to try to do this by hand. So let's look at number 22. So f of x equals 1 over x minus 3. All right. So what I see first is x can't be 3, right? Because 3 minus 3 is 0. So if I go out here to 1, 2, 3, since 3 makes the bottom 0, and it doesn't, there's no x minus 3 up here to cancel with. This is a vertical asymptote. All right, so there's one thing. Can this equal 0? I don't believe it can, right? So I don't think this is going to, let's see. If I try to do 1 over x minus 3, is there an answer? Can you solve that? Is there any way 1 over x minus 3 can equal 0? Well, if you try to multiply both sides by x minus 3, it's just going to go away, and you're going to end up with 1 equals 0, right? So 1 equals 0, which is nonsense. 1 does not equal 0. So it's impossible, right? You can make the bottom 0, right, by making x 3, but 1 over 0 is not 0, is it? 1 over 0 is basically infinity, or what we say is undefined. So there are no zeros. So no zeros. What about horizontal asymptotes? Okay, horizontal asymptotes. This is what I would call, as I was saying up here, this is proper, right? This is proper because the degree of this polynomial, and believe it or not, 1 counts as a polynomial. The degree of that is 0. Think of that as x to the 0 power up here. And the degree of this one is 1. So 0 over 1 is proper, since the degree of the top is smaller than the degree of the bottom, which is the denominator. Therefore, the x-axis should be an asymptote as well, right? Okay, so I know that you have two asymptotes. You have a vertical asymptote. The equation of that is x equals 3, because it goes through x equals 3, and everywhere on the line is x equals 3. And y equals 0. The x-axis itself is another asymptote, so I can write that down for you. So vertical asymptote is x equals 3. Horizontal asymptote is y equals 0. All right, now we need some more points if I'm going to graph this thing. So let's see what's going on maybe at 2. What happens at 2? So let's make a table down here. So I have x and f of x. If I make x 2, then that's 2 minus 3, right? 2 minus 3 is negative 1. So 1 over negative 1 is just negative 1. So I know the point 2, negative 1 is on the graph. What about 2.5? As we get closer to this asymptote, what happens? So what about 2.5? Let's see what happens there. So if I put 2.5 in, 2.5 minus 3 is what? Negative 1/2. And 1 over negative 1/2 is negative 2. So that means when you go over to 2.5, now you're down to negative 1, negative 2. And as you can see, as you get closer to this line, that denominator is going to get smaller. And when you divide 1 by a really small number, you're just getting a very, in a sense, large negative number. So let's put it in here so we can 1 divided by x minus 3. Go to my table. All right, so now I'm looking at numbers close to 2 in between 3, so like 2.5. So what I'm going to do is go to the graph. There's the graph. Let me blow this up. All right, and then what I could do is go to second trace and put in value. And this allows me to put in whatever x value I want. So if I want to put in 2, it gives me -1, just as we wrote down here. When x is 2, y is -1. I don't think I've ever taught you this before. Okay, go back to second trace again, choose value again. Let's put in 2.5. Now I get -2. All right, let's get closer. Let's get closer to 3. So how about 2.9? What's going to happen? So second trace value, 2.9, -10. All right, so now when you're really close to approaching from this direction, it drops way down here to -10, which is way down here somewhere, right? So obviously this thing is going to do something like this. And then it's going to come up. It won't touch the x-axis because it can't be 0, but it's going to skim this way. It's going to do that. We can find this just by making x 0. So when x is 0, so if I do second trace value and make x 0, I get, as you can see, that's -0.3 repeating. So that's -1/3. So when x is 0, I get -1/3. So that's what that point is right there. 0, -1/3. All right, what about the other side? You can see the other side does this thing. So if you get close to 3 coming from the positive direction, it does this, and then it's going to pretty much be symmetric with this graph here, but on the other side of the x-axis. Something like this. All right, and we could find some points there. So like I think probably at 4, I'm going to get 1. So that should be 4, 1, right? Because if I put 4 in here, 4 minus 3 is 1, 1 over 1 is 1. So 4, 1 is another point on the graph, which is here. All right, so that's it. That's how you graph that. Recap. It's a proper fraction. Therefore, the x-axis is a horizontal asymptote. 3 is not in the domain of this function because it makes the denominator 0. And x minus 3 does not cancel with anything on top. Therefore, 3 will be your vertical asymptote. So that's right there. X equals 3 is your vertical asymptote, that vertical line. So now I've got 2 asymptotes. There is 0. You can't make this 0. Therefore, it never crosses. We should know that since, I mean, usually when the x-axis is an asymptote, then you're not going to have any zeros. But that's not always the case. There are situations where the graph can cross an asymptote. And we'll run into that later. So there's no zeros. And then we just plotted some points to get a better picture. Backed it up with our graphing calculator. All right, so that was 22. Let's take a look at 26. Is p of x equals 1 minus 3x over 1 minus x. Okay, so draw a graph. We see that 1 is a no-no, right? X cannot equal 1, so there should be a vertical asymptote there. x equal 1. Now you got to be careful because that could be a hole, right? So if 1 makes the bottom 0 and the top 0, then it's a hole, not an asymptote. But in this case, 1 makes the bottom 0, but not the top. So it's just a vertical asymptote. All right, this isn't exactly proper because the degree of this is 1 and the degree of this is 1. Since they're the same, to find any horizontal asymptotes when they're the same, you just put this leading coefficient over this leading coefficient. Now these are both negative. So when you put 3 over 1, negative 3 over negative 1, you get 3. So that means, hold on, I forgot to write down my vertical asymptote. That was x equal 1. All right, horizontal asymptote. It's going to be y equal negative 3 over negative 1, which is just 3, right? So if I go up here to 1, 2, 3, I should have a horizontal asymptote up there. All right. I can find my y-intercept by making x 0. So if I want to find my y-intercept, I can just do p of 0, which is 1 minus 3 times 0 over 1 minus 0, which is what? 1 over 1. So right here is your y-intercept at 1. All right. Can you make the numerator, are there zeros? Or x-intercepts, right? Yeah, because the top can be 0. So what I would do is I would take the top 1 minus 3x, and I would set that equal to 0 and solve it. So that's going to be, I'll just take away 1 from both sides. So that's going to be negative 3x equals negative 1. So x is 1/3. So right here, here's 1. So 1/3 is right about there. So there's your x-intercept. So I've got a y-intercept and an x-intercept. So I can kind of see what's going on there. It's going to doing something like this. And it's going to approach this asymptote going this way. If I want to, get a better point, maybe I'll put in a negative 3 to see what that point is. So let's see, I've already plugged in 0 and I got 1. When this is 0, this is 1/3, so there's another point I've already got. When x is negative 3, what do I get? Let's see. So what is p of negative 3? P of negative 3 is 1 minus 3 times negative 3 over 1 minus negative 3. So I'm just plugging negative 3's into these two x values. This gives me 1 plus 9 over 1 plus 3, so it's 10/4 or 5/2 or 2.5, right? So 2.5 is that point right there. So that should be up to 2.5. Doesn't look like it. My graph is not super good. I'm not using graph paper, but that coordinate right there is negative 3, 2.5. The other graph is going to be same as this, but it's going to be over here. It's going to do this. So let's get a couple of those points. So let's try, there's 1, let's try 2. What happens when I plug 2 in? So what's p of 2? So that would be 1 minus 3 times 2 over 1 minus 2. So that's going to be 1 minus 6 over negative 1, which is negative 5 over negative 1, right? Negative 5 over negative 1. So 5. So when I plug 2 in, I get 5. So 1, 2, 3, 4, 5. So that's a point on the graph right there, up at 5. And I'll pick a point like, how about 4? Let's try 4. What happens there? So P of 4. So that's going to be 1 minus 3 times 4 over 1 minus 4, which is, what, 1 minus 12 over 1 minus 4, so negative 11 over negative 3, 11 thirds. Let's estimate that. What is 11 thirds? About 3 2/3. So 4 would get 3 2/3. So there's 3. 3 2/3 is just a little bit more up. So, you know, we can start to see this curve right here. So it's coming up this way, and then it's going to shoot up right here and start approaching that graph. Just something like that. So let's put it into Desmos and see how it looks. All right, so f of x, or this is p of x, equals 1 minus 3x over, oh, I messed up. I got to put that in parentheses. Um, 1 minus x. All right, so how did we do? Let's see. So we plugged in 4. Here's 4. As you can see, at 4, it's, oops, can't exactly find 4. Well, as you can see, it's really close to 3 2/3. I'll just do it this way. P of 4. There we go. Okay. And what are those? We found 2, 5. So 2, 5 right there. And so on. All right. That was number 26. All right, let's look at 32. (32) is g of x equals x over x squared minus 9. Now, you got a quadratic here. Factor it if you can. In this case, we could factor that. So that's x over x plus 3x minus 3. It makes it a lot easier to see what's not in the domain. So it looks like I have 2 asymptotes this time, right? Negative 3 and positive 3. So vertical asymptotes. X equals negative 3 because of x plus 3, and x equals 3 because of x minus 3. Horizontal asymptotes. This is proper. This is x to the 1, this is x to the 2, so that's small over big. Therefore, y equals 0 should be a horizontal asymptote. Zeros. Obviously, 0 itself should be a 0. So it does look like we're going to cross this asymptote this time, because y equals 0 is the x-axis, but we do hit the x-axis when x is 0. So it looks like 0 itself is a 0. So 0, 0 is on the graph. All right, so let's start graphing it. So I go over 1, 2, 3, make an asymptote here. Go this way, 1, 2, 3. Another one here. Let's see what happens when I plug some other numbers in. So when I plug 0 in, I know I get 0. So that's on the graph. Okay. Let's see what's going on in here. So let's plug 1 in. So if I plug 1 in, I get 1 over 1 minus 8. So negative 1/8. So like really close to the x-axis. If I plug 2 in, I get 2 over 4 minus 9, right? 2 over 4 minus 9 is negative 2/5. All right, so that's a little bit further down. Now I can't plug 3 in because it'll give me a 0 in the denominator, but I get close, right? So I could do like, what about 2.5? So if I put 2.5 in, so on the top is 2.5 divided by 2.5 squared minus 9, I get almost negative 1. So at 2.5, I'm at like negative 0.9. So that's negative 0.91. How about 2.9? What happens? So I'm just going to replace this 2.5 with 2.9. Almost negative 5, right? Negative 4.9. So when you get really close to this line, you're already down here, like negative 5. So we can see it's doing this. And my guess is it's going to do something like this on the other side, just from experience. I hope I'm right. Because when I turn this around, when I make all these negative, so for instance, if instead of 1, if I make this negative 1, well, that negative 1's on the bottom is just going to stay. When you square it, it's going to become positive again, just like it was when I plugged a positive in. So it's just going to switch the sign. So this is going to be 1/8. Right? So that's going to be 1/8 right there, and so on. So these numbers, like negative 2, should just be the opposite of that, which is 2/5. And at negative 2.5, I should get positive 0.91, and so on. All right, so that's what's happening in between the two vertical asymptotes. Now, what is happening outside? So for that we would need to know what's going on at 4 and in between 3 and 4, for instance. So let's, for the sake of time, let's cheat a little bit and just do x in the graph, x divided by x squared minus 9. We'll graph that and see what's going on. Right? So this is, you can see how the x-axis, even though it got crossed here, it's an asymptote for this part of the graph. And it's also an asymptote for the right side. All right, so that's it. That's the graph. Number 32. I think I'm going to do one more. Let's do... All right, I may regret this, but I'm going to do 40. So f of x equals x squared minus x minus 2 over x cubed minus 2x squared minus 5x plus 6. You know, I completely forgot to do the symmetry test thing. All right. So step one, what do you want to do? You want to factor it if you can. So let's see if we can factor this. Are the two numbers multiplied to negative 2 but add up to negative 1? I believe so. It's x minus 2, x plus 1. Right, so negative 2 times 1 is negative 2. Negative 2 plus 1 is negative 1. So that's the top. The bottom, that doesn't look like that's gonna factor. I don't see it factoring. Did I copy it down right? Yeah. So for instance, if I try to group this, when I pull x out of here, there's nothing I can pull out of here. It's going to be the same. So I don't see this factoring at all. So I think I'm just going to have to leave it as is. Okay. So it's going to be very difficult to find the zeros of this thing unless we use the, if we're doing this without the calculator, we would have to use the methods. So maybe this is, I guess, a good review, and it's probably the purpose of this. So are there any factors of this? Well, we know if there are factors, they have to be factors of 6 over 1, so factors of 6, right? So that means the factors of 6 are technically over 1, but you know that's kind of not really useful. So it's plus or minus 1, or plus or minus 2, or plus or minus 3, or plus or minus 6. So I'm going to take a guess and assume there's a hole in this graph because I know on the top 2 makes this 0 and negative 1. So I'm going to start there. Just, it's a wild guess right now. So let's try 2. So that'd be 1. I'm doing synthetic division just like in the last section. 2, that's 0, 0, negative 5, that's negative 10. That doesn't work. All right, so I can forget about 2. Let's try negative 1. 1, negative 2, negative 5, 6. That's going to be negative 1, negative 3, 3, negative 2, 2, 8. That doesn't work, so I was wrong there. Okay, so those don't work. How about, what else could I try? Let's try negative 2. Negative 2, negative 4, 8, 3, negative 6. Yay, I got lucky and I found one. Okay, so now I know that since I tried x minus negative 2, that means this bottom will factor to x plus 2, because negative 2 makes that 0, times x squared minus 4x plus 3. Okay, so now I've factored the bottom. And I think this will factor, because negative 3 and negative 1 should work. Negative 3, negative 1. So in other words, x squared minus 4x plus 3, doesn't that factor to x minus 3, x minus 1? Right, because negative 3 times negative 1 is 3. I believe it is. So now, I think I've got this thing completely factored. Okay. So I'm going to rewrite it. So f of x is equal to the top, which is x minus 2, x plus 1, over the denominator, which is x minus 3, x minus 1, and this other one I found, which was what? X plus 2. So as you can see, perseverance pays off. Now, I think there's got to be a better way to factor this. If you figure it out, let me know. I'm sure I'm just forgetting something, but I found them by using synthetic division. All right, so what do I know then? I know that nothing cancels, right? Nothing cancels on top and bottom, so there are no holes. So if I'm looking for holes in the graph, there are none. What else? It looks like there's 3 vertical asymptotes. So vertical asymptotes, I've got x equals 3, x equal 1, and x equals -2. So 1, 2, 3, there's a vertical asymptote. At 1, there's a vertical asymptote. And at -2, there's another vertical asymptote. There are also zeros. 2 will make the top 0, so x equals 2 is a 0. So I know at 1, 2, there's a 0 right there. And at -1, so right there is a 0. All right, what else? I know that this is a proper fraction because the top is degree 2 and the bottom is degree 3, which means for a horizontal asymptote, y equals 0. So the x-axis is some sort of asymptote. Obviously not in between these, something's going to happen in here, but as the graph goes out, I think it's probably going to do something like this, and maybe something like this. I don't know. We'll just have to plug in and look at the function and see what's going to happen. All right, so let's take a look at this and see what is going to happen. Because the video is getting a little long, and I don't want to use up any more time. So let's graph this and see what we get. I'm going to put the original problem in. All right, f of x, the unfactored form, equals parentheses x squared minus x minus 2 divided by x cubed minus 2x squared minus 5x plus 6. And there it is. So you can see that the graph does do this. It's a little sharper curve here than I drew, but it does something like this. And on the other side, it does do the same thing here, just a little sharper curve. Okay, and then here it comes down along this asymptote and then turns and then goes down along the other one. And then it does something very similar in here. It actually comes down this side of this left asymptote, and as you approach it, it curves and has a little inflection point and then crosses the y-axis and then turns back down and runs along the other asymptote. All right, and there's your graph. And that's enough for today. All right, thanks so much for watching. God bless you guys. Have a great day.